Hello, this is Oliver von Leyen. I'm the inventor of code for the TwistBlock technology, which you can use to build curved houses like the one that you see behind me. And I'd like to introduce you our official TwistBlock planning tool that we have programmed for Grasshopper in Rhino. So let's go ahead and try and design a building that fits into that very plot here. Here we just created that imaginary layout with the road with the adjacent plots. And yeah, let's try and have some fun with our new software. So I'm opening a recent file here, which is the TwistBlock script, and see what's happening. So the first thing the script does is to create a bunch of layers here, quite a few layers. If I hit the layer button here once, twice, it basically brings me everything in the correct order. So first of all, we see a layer 01 starts somewhere input. So basically that's all you need, all the layers that you need for designing. That's what you as a designer basically need. 2D is then later on, everything that the code generates in 2D that can then be brought back into Rhino. 3D as well, init elements like things to be exported for the structural engineers, and implementation plans that are also generated automatically. So let's look at it. And here we have a user interface, and I'm gonna guide you through this interface a bit later on. For now, you just see a bunch of switches, which they are all switched off currently, which is totally fine for us at this stage. And we just go into this plot and we just start, drafting some wall. So we go onto the correct layer, which is in our case, wall A. We always start with wall A. And we are in 2D vision. And we just go ahead and we'll just draw a curve just here, right on plot boundary. And somewhere here, and whoosh, we see automatically we get a 2D representation of the twist blocks that are already automatically shortened. We get the one fin block here on the corner, and yeah. Then of course we want to make maybe a bit of a curved line here to let's see. Let's make a spline then. So we go up here a bit. Maybe we want to create some little space here. I don't know, go to the end here. There we go. We've created that kind of funky curve. Let's adjust it a little bit afterwards. And maybe you see we're ending here with a half block. Maybe we don't want this, so we want to make our curve a little bit longer. So what that code does, basically, it automatically stretches our initial curve or shortens our initial curve to a multiple of half a block, so to say. So that's basically what's happening here. And maybe we also want to drag those control points a little bit over there so we don't end up with half a block, just for the sake of easiness. Even though there's no problem working with half blocks. Sometimes it's just more convenient to have the full ones here. Cool, so here we are. Let's not get too much driven up in the design. We create a little square here. Maybe a tree can grow there or something like that. So that's cool. So we have a 2D representation of our block plan layout, and which is also super fast to design with. And now what we can do is we can here look at our user interface. The first thing is that switch that we can manipulate by double-clicking on it. So it asks us, do you want to switch on the blocks in 3D? And I would say, definitely, let's do that. And let's maybe not do that in 2D view, let's do that in perspective view and check out what our building would look like in 3D. So for that, I designed it in that way that you have to switch on the render preview. And there we go. So now we get a 3D representation of our blocks here. What we can always do is we can alternate the number of courses. Let's just stick to 14 for the time being. We can alternate the level of detail. Let's maybe see what it gives us with a level of detail of 2. Okay, here we see the blocks the way they really are. And level of detail 3 is really just for a very small kind of wall, because it would give you a NURBS representation of the walls, which easily may crash your machine if you have a very big file. So I would recommend not going really higher than 2 unless it's really needed. So what else can we do? We can then, for example, create a separation wall. So here you see you have wall A, and then you have wall B, wall C, and wall D. So I'm going to guide you through what those different kind of wall types mean next. So wall B basically is what you need if you want to put a T-junction onto wall A somehow. So basically we're looking at just making a curve. Let me snap to a near point, maybe to a perpendicular point as well. So I'm just snapping onto that line here, going over there, just somewhere as an example, hitting enter. And you see it automatically makes a wall that interlocks with wall A. So that information you can only get if you basically have wall B hitting wall A. Otherwise, the code doesn't really know what to do. So from there, we could create maybe another separation that goes from this wall to this wall. And for that, we would, for example, now use wall C. So let's go snap somewhere here and go somewhere there. Cool. And wall C basically allows us to make a wall that interlocks with wall A and wall B at the same time. It looks a bit funky, doesn't it? Let's change this. I don't actually have to be right on the wall, because you see the code actually makes it snap to where it should be. If I just move it a tiny bit, you will see the wall doesn't move. If I move it a little bit more, boom, it moves right to the next point where it can snap to. So that's what it does. Cool. So, and you may wonder, okay, what do you need wall D for? Wall D, you need in order to extend wall C coming here. So maybe let's try and start it off here. And I don't know, let's just go somewhere here. So now we got wall D coming there. And why do I need wall D? Well, if you count from the top down here, you see you have the top course like hitting this wall. And then you have the second block here interlocking. Versus if you look at the other wall, wall C, you have the 1, 2, 3, the third block interlocking into that wall. So meaning otherwise you would get a conflict between this and that wall. It will become quite intuitive, like once you get to work with the code a bit more, what kind of wall you need to use at what point. And what you also see is we have a certain color code for the different kinds of blocks that are required here. So sometimes you need like a short block like this, which is a half block basically that sits on the on this particular end, the other block where you have the fins. And then this colored block is basically the same. It's also half a block. It's just a bit longer because it sits on the round end of the block. Yeah. So then you have this block, which is a single fin block, which is always needed at points where you have a curvature or where you have an angle higher than 45 degrees. And that's pretty much all you need. Even though, sorry, I forgot, you also have this kind of block that has no fins anymore. That's what you need in a situation like this when you want to end the wall. Yeah. So basically you have the freedom to design with a horizontal resolution of 250 millimeters. So which is half a block. Okay, so far we managed to bring out that little structure. Let me just make this a little bit nicer by turning on the ground plane. I always want that to be more appealing. Let's switch to perspective view. And then we can imagine a bit more how that, I don't know, it could be a small exhibition hall or maybe a small dwelling for a family or single household to live here. Yeah, cool. So what else do we want? We may want to get into the building somehow, so we need some openings. So I'm going to the layer, opening boxes. And I'm just going to create here a box in Rhino, just a normal box. Corner to corner height, just, I don't know, make it 2 meters, 2000 in height. Cool. Here we get that box. It's important that you're on the correct layer. You're on opening boxes, right? And you may want to give that layer some kind of transparent material like glass. Cool. And just push it up. Okay. Nice. So now it's not necessary, but it's just nice to look at. Now you can take this box and just push it into the wall somewhere, and whoosh, it will create an opening automatically. You can rotate it, whatever you want with it. You can make it bigger. You can, yeah, let's not make it too big. And then we have a door. So what we want to do is maybe we want to push it up using the gumball and writing in here 175 millimeters, which is exactly the height of one course. Why? Because that allows us basically to have that very first row continuous, because we may want to cast a slab inside. And like this, thinking of construction later on, we can be sure that our opening will be perfectly fit into multiple of block sizes. So yeah, lesson learned showed this is a pretty good idea to have the first row like this. Cool, so we have a door to get into the building, and maybe we want a few doors inside. So, oh, I distorted that box quite a bit. Let me just bounding box around this. And cool. Just make it a bit smaller. Interior doors don't have to be so big, right? So we rotate this guy a little bit and just push it somewhere in here. Working plan. And then I'm just copying it from here to there to here. Just making sure I get some access to all of those rooms. So far, so good. And I can see it automatically trimmed some openings into here. Oh, this door is a little bit tiny. So let's just make it a bit bigger by scaling it two-dimensionally. There we go. So we have a big enough door. Cool. And in the same way, that's why they're called opening boxes. We can also just make a window. And for that, let me just copy one of those boxes over here. Just here. And oops, what happened? I think I accidentally messed something up. Let me just copy that again. Undo is always a good button if something like that happens. But it usually doesn't happen, never happened before, just in that tutorial now. So let me scale this, snapping to the endpoint, just make it, I don't know, at height. And let's say it's a bit wider, be a window. Just over here, a little bit bigger. That's cool. And just copy this a few times. Copy it here. Copy it there. Another window here, maybe. Another window over there. Copy. Oops, that was a bit close to the corner, I guess. And let's just make another one here for now. Good. Takes a moment to calculate. And this one, we want to push it a bit off the corner. And get back to perspective view. Cool. So now we can already imagine, oh, it looks kind of like an inhabitable structure. Let's go to the next layer that we need. We see a layer called door points. Let's go to that layer and switch off our layer opening boxes. Good. So now what basically the code needs, it needs to know which opening is supposed to be a door, and which opening is supposed to be a window. So for that, I'm just making multiple points, right-click on point object, and just going here, and I'm just clicking near to the doors, and making some point there, just to inform the code about the fact that this is supposed to be a door. And need to do something here. So I'm saying in the code here again, activate doors or windows in 3D, and a double click and say true. And you see, suddenly these guys know they are doors. The special feature about the doors is, you see, it also shows in plan, like which way the doors open. So if I want this door to open maybe just the other way, I just have to push this button, this dot over here, or if I want to push to open it on the other direction, I just push it on the other side. I just push it there. So simple as that. Freedom as the designer. Now I want these other openings to be windows. So I go to the layer window points, and I create multiple points. And I just have to be close enough to those windows. I can even snap to the line. It doesn't matter because for the windows, the opening is not so important right now. I hit enter and whoosh, it automatically creates some windows, which is okay for visualization, but I think it's also important then later on for the mass calculation. And we can play a little bit with the values here. So we can play a bit with the depth of the window frame. So for example, we want to go a bit for, oh, sorry, that was the width. Yeah. So we want to make it more slender maybe. And we can adjust also the depth. So we could also have like these windows sticking out of our building. I mean, it's just for playing a little bit with the design and having some quick kind of nice visualization. Good, so far so good. We can already imagine this is looks like a house that we can live in. We have all that interlocking logic that we usually would have to think about quite a bit, so that we make sure all the blocks are correctly interlocked within the masonry logic. And that is what is automatically solved by the code. And you see, it becomes quite complex the more you have openings, the more you have walls hitting each other. So it's quite handy if the code solves all of that for you. Cool. So next, let's see what else is in there. What can you get out of it? Activate foundation. Let's just double click that. Okay, it automatically gives us the foundation that we can strip foundation underneath the building. It can be also, we can play with width and with the height of that foundation, depending on what the structural engineer will tell us. And then let's see, activate slab, ring beam, and gypsum. What does that mean exactly? So let's double click it. Okay, so now we have a gypsum board that covers basically our top floor. And we can see here we have a ring beam in there. And yeah, activate columns 3D. We don't need to activate that yet because we have not yet made any columns. Columns are sometimes required to be cast inside the hollow blocks. That's for horizontal stiffening of the building against earthquake, which is usually an information that comes from the structural engineer. So let's assume we have that information now, and we want to get it into there. So you see, pretty much we can now already imagine, okay, if we have a building, we can go inside a little bit, check out what it's like inside here. So what we already have is pretty much enough for a good visualization company to do a nice rendering for us. And we already have enough to actually start constructing with the box. But we want to go a little bit deeper and also look at the structural engineering part of it. So let us just switch off everything for now. Switch off all of those things that we don't need. So I basically reset everything to false. I just close my input folder and I'm going here to number 4, start somewhere finite elements. And I'm going to the layer column points and make that my current layer. And I just switch off the input layer. So you see there's nothing left. I even switch off the default layer. So we just have that pure 2D layout remaining. And here's a button. It says make center curves only. So that's what you need for the next step. So let me hit that button. Whoosh. Here we go. So now we have the center curves. Those center curves basically are single segments that always go from center of the block to center of the block. So if you right click on the end snap, you make sure that whatever you draw, you always draw on that very end point. We want to now set column points onto those endpoints. So typically we have 3 kinds of columns. So let me just make the first kind of column. So that's a column type 3, which is basically stretching over 1, 2, 3 half blocks, you could say. We have a column type 2. Well, let's just put one maybe here and another one here. I'm just putting some columns, you know, I'm just assuming this might be sort of where we want to have some columns. It really, you can't get a universal recipe of where to place the columns. It all depends on the local earthquake situation, how you want to, how you need to stiffen your building. Maybe another type 2 here, why not? Yeah, probably in the curved part. Oh, that's where the door is. So maybe let's do one here. Cool. So and here it automatically creates a column type 1, but I think that's what it was. So let me just delete that one. Cool. So what you see now is the code automatically generates a triangulation plan that you can then give to your engineer on site, which will make it easier to make that layout of that freeform kind of shape that you have drawn. So, and here we have the columns also in there. So they are marked in 2D. So meaning in these areas, we want to make sure there will be some concrete cast inside. Let's hit this one, activate columns 3D. Just waiting a moment, there we are. And look at this in perspective. Okay, so we can now imagine we have the 3D volumes of those columns as well. So now we can go back to activating all other structural elements. So now we can see really what structure. Well, okay, this is a heavy earthquake situation, yeah, where we need all that stiffening, we need the ring beam, we need the strong foundation, we have floor slab that's on the inside, and yeah. So now we can go back to switching on the twist blocks, and we can switch back on our doors and windows, and now we can say, basically, except from the steel, our structure is complete, and we can do another little tweak, which is quite handy. We can export our statistics that we get out of here to an Excel sheet that we can use as a base for making a bill of quantities. So we just go and zoom here a little bit over there. We get all our statistics. So we have our wall height, our gross floor area, number of twist blocks, number of doors, number of windows, window area, roof area. So basically that's a multiple of that plot area. The volume of the foundation, the volume of the columns, volume of the ring beam, volume of the floor slab, and the area to be covered with the gypsum board. Basically all those values, we don't want to, we're lazy, you know, we just want to click one button. And for that, we have in our user interface this part. where it says set path to an Excel sheet. So I'm going here, right click, and say select one existing file. And here we are. It says TwistBlock example numbers, which I've prepared already. And okay, I say open. And the file, this is important, the file has to be closed while I'm clicking this button. And I can give it a certain title, whatever. I can call it house 01, for example. And now I click that button. Boom. And basically we wrote now that Excel sheet. So let me just browse for the sheet quickly and I show that to you. And here we are. Excel opening on my machine. Will take a moment. Not so bad. So here we see we just put in there sample house 01. So I have that normal tab, I have a grasshopper tab, which will always update every time I press the button. And all the information I have extracted here. And basically, if I'm now a smart quantity surveyor or a smart project manager, I can just reference those numbers into my bill of quantities, and then I'm very fast with calculating and making offers. That saves a good amount of time. Cool. So that's basically what the code can do from the point of, first of all, visualization and cost calculation, so quantity calculation. And now we want to look into the part where it becomes structural. So let me open a separate script for that. Oh, sorry, I forgot one thing. So once you're actually done, you can just hit one button and then all that geometry that you have here, because now it's just virtual geometry, you cannot touch it. You can just also press that button and then everything is in Rhino. It's there as a dead geometry, which you can then pass on to your visualization office and have somebody render it. Or you can play yourself with it if you prefer, like doing it maybe manually to a certain extent. Cool. So let me just open a new rebar file. It's this one, basically. That's what we need. And it looks so far so good. So that's maybe not so spectacular, so we don't have to adjust a lot here. So all we have is those three preview elements. And first there's a certain code with it. But that's pretty much the user interface, because rebar doesn't allow really much tweaking. So let me just push this aside and we look at what we got here. So we have basically automatically generated all the rebars, like even the stirrups. We have the 16mm green ones for stiffening the building. We have the 12mm, that's the red ones. And we've, yeah, basically everything there. So from that, we can easily extract also the amount of steel that needs to be ordered. The bending schedule can be done very simply. And the big advantage is we can just take this file, send it again to the structural engineer for approval. And we can also make sure, like on site, that the project manager, the foreman, makes sure the rebar is perfectly implemented like that. So yeah, that's basically how it works for the whole building. So this is our first introduction to the code, and I hope you enjoyed it, and see you soon. Cheers.